Solving systems of equations by graphing. Let's start with some terminology. A system of linear equations consists of two or more linear equations containing two or more variables. A solution of a system of linear equations is any ordered pair that makes all the equations true. All solutions of linear equations can be found on its graph. A system of two linear equations may have one solution, no solution, or infinitely many solutions. To solve a system of linear equations by graphing, it is helpful to write the equations in slope-intercept form. We'll take a look at our first example, and we'll use technology to solve this problem. At first, tell whether each ordered pair, namely 1, -2, and 3, -1, is a solution of the given system. So I will type in those two linear functions into Desmos.com and take a look at the graphs. If there is a point that those two graphs intersect, we call that point the solution to the system. So we can see 1, 2 is the solution to the system, and the other point, although it does lie on one of the graphs, because it does not lie on both, is not a solution. Now let's solve this same problem using an algebraic technique. So in the first ordered pair, 1, 2, let's substitute x equals 1 and y equals 2 into this first function. Let's simplify the expression on the left and notice that this is a true statement, telling us that 1, 2 definitely lies on that line. Now let's plug those same x and y coordinates into the second function. So we'll have 1 equals 7 minus 3 times 2. Let's simplify the right-hand side. Notice this is also a true statement. Therefore, 1, 2 is a solution of the system of linear equations. Now we knew from the graph 3, -1 was not a solution, but let's show why it isn't algebraically. Let's substitute x equals 3, y equals -1 into the function, and let's simplify the expression. I do get a true statement here, which tells me 3, -1 lies on the first function. But when I plug this point into the second function, I do not get a true statement. In order for an ordered pair to be a solution, it has to lie on both lines. Therefore, 3, -1 is not a solution of the system of equations. Okay, now let's get some actual practice graphing, right? So here I have two lines. They are in slope-intercept form. Let's graph the line y equals x plus 3. We'll start at the y-intercept, and the slope is 1. We'll connect the dots, and there is my line y equals 1x plus 3. Now the second line. The y-intercept is 1. The slope is 2. So up 2 and to the right 1. Up 2 and to the right 1. That is the point at which the lines will intersect. The coordinates of that point are 2, 5. Therefore, 2, 5 is the solution to the system of equations. Now we can prove this algebraically by substituting x equals 2, y equals 5 into both equations. And since we have a true statement here, that shows me 2, 5 is a solution to the first equation. Now let's substitute 2, 5 into the second equation. This is also a true statement, telling us that 2, 5 is definitely the solution to that system of equations. We have another example. It says to solve the system by graphing, then check your solution. Now you could certainly write these in slope-intercept form. But you could also, because the numbers are going to be compatible in the standard form equation, we could make a table of values. And if x equals 1, y would equal 6. If y is 0, x would equal 3. And we could plot these 2 points. And here's our first line, 3x plus y equals 9. Again, I could turn that second equation into slope-intercept, but I'm noticing in standard form the coefficients are compatible with the constant term. So I can make a table of values. If x is 0, y is 4. If y is 1, x is 6. I can graph these 2 points and connect them. And I can see that 2, 3 is the solution to the system of equations. So again, I've solved this by graphing. I can prove it algebraically by just substituting x equals 2, y equals 3 into both equations. And I'm noticing that I'm getting a true statement. Okay, we'll do one more example using a graphing calculator this time. So I'm going to, I guess we could first write it in slope-intercept form, especially if you don't have Desmos, but you have a graphing calculator. You're going to want to do this. And when you type them both in, the first equation with the y-intercept of -2 and the slope of -2 is graphed. The second equation has a y-intercept of -5 and a slope of -3. Using the technology, -3, 4 is the solution to that system of equations. Now we can prove that this is the solution by substituting x equals -3 and y equals 4 into one function. We can do the same into the other function.